Hello children, let us start trigonometry part 2. So, I have already discussed the various ratios and the trigonometric identities that we will be using. So, let us start solving question number 12. Tan square A prove that tan square A minus sine square A is equal to tan square A sine square A. Okay, so consider LHS, that is what, tan square A minus sine square A. Now this tan A can be written as sin A upon cos A. So this is tan square A, so sine square A upon cos square A minus sine square A. So here you will have to write, we have used tan A is equal to sin A upon cos A. Okay, so now this is denominator is 1, so this sine square A minus sine square A cos square A, these two I am cross multiplying like this, okay, upon cos square A, then you multiply these two, that is cross multiplication. So this implies, now you can take out this sine square A common. So if you take out sine square A common, 1 minus cos square A upon cos square A, right? So this implies sine square A upon cos square A is tan square A, and this can be written as tan square A into 1 minus cos square A. So again we have used sin A upon cos A is equal to tan. Now this implies tan square A, 1 minus cos square A is sin square A. So we are using 1 minus cos square A is equal to sin square A. That is nothing but RHS. Okay. So therefore LHS is equal to RHS, hence proved. Cosec A plus sin A into cosec A minus sin A is equal to, we have to prove cot square A plus cos square A. Okay, so again consider LHS, that is cosec A plus sin A into cosec A minus sin A. So this is of the form A plus B into A minus B, so that will be equal to A square minus B square, that is cosec square A minus sin square A. This is A plus B into A minus B is equal to A square minus B square. Okay. Now cosec, what we have, cosec square A. Now cosec square A can be written as 1 plus cot square A. Okay, so this implies 1 plus cot square A minus sin square A. This is because cosec square A is equal to 1 plus cos square A. So this implies now this can be written as cos square A plus 1 minus sine square A. Just I have rearranged the position. Okay. So this implies cos square A plus this 1 minus sine square A is cos square A. 1 minus sine square A is cos square A. And this is equal to RHS. Therefore, LHS is equal to RHS, hence proved. Okay. Then the next one is similar one, you will do it. Prove that sec A minus cos A into sec A plus cos A is equal to sine square A plus tan square. This is similar to the previous 14th one. So you can do it as homework. Now 16. Cos A plus sin A whole square plus cos A minus sin A whole square is equal to 2. So again consider LHS. Cos A plus sin A whole square plus cos A minus sin A whole square. Let us apply A plus B whole square, A minus B whole square. So this will be cos square A plus sin square A plus 2 cos A sin A plus this will be cos square A plus sin square A minus 2 cos A sin A. This how by applying A plus B whole square is equal to A plus B whole square is equal to A square plus B square plus 2AB and A minus B whole square is equal to A square plus B square minus 2A. Now plus 2 cos A sin A minus 2 cos A sin A cancels. So you are left with, and cos square A plus sin square A is 1, cos square A plus sin square A is 1. So 1 plus 1, that is equal to 2. Here we used sin square A plus cos square A is equal to 1 identity. So that is equal to RHS. Therefore, LHS is equal to RHS. Hence, proved. Now, question 17 is homework for you. Prove that cosec A minus sin A. These are reciprocals, isn't it? Cosec A is 1 upon sin A. That is what you will use. Cosec A minus sin A into sec A minus cos A. Again, sec A is reciprocal of cos. into tan A plus cot A. So again tan and cot, tan A plus cot A, they are also reciprocals to each other. This is equal to 1, you have to prove. So use the reciprocals and try to solve it, you will get it. Okay, so for cosec A you will write 1 upon sin A, for sec A you will write 1 upon cos, and for tan A you will write 1 upon cot A, and then try to do it. Okay, if you don't get, you can ask me. So now next question. The next question is prove that 1 upon sec A plus tan A is equal to sec A minus tan. Now consider LHS. So what is our LHS? 1 upon sec A plus tan A. This can be written as or let us multiply. This is like how you used to do in rationalization. You used to multiply by the rationalizing factor. In a similar manner, we will multiply the numerator and denominator by sec A minus tan A. Okay, so multiply numerator and denominator by sec A minus tan A, we get sec A minus tan A upon sec A plus tan A into sec A minus tan A. Okay, so now this implies sec A minus tan A upon, this is A plus B, A minus B, so sec square A minus tan square A. Here we have used A plus B into A minus B is equal to A square minus B square. Okay, now but what is sec square A minus tan square A? That is equal to 1. So this implies it becomes sec A minus tan A. What is the reason? Sec square A minus tan square A is equal to 1. So this is nothing but your RHS, and therefore LHS is equal to RHS, hence proved. Okay, then 19th one is a similar one. You do it as homework. Prove that cosec A plus cot A is equal to 1 upon cosec A minus cot A. Okay, okay, now children, as I told you, now question 20 we are doing. Question 19 is homework for you. Prove that cosec A plus cot A is equal to 1 upon cosec A minus cot A. Now question 20 is prove that sec A minus tan A upon sec A plus tan A is equal to 1 minus 2 sec A tan A plus 2 tan square A. Now again consider LHS. So LHS is sec A minus tan A upon sec A plus tan A. So we will multiply a numerator and denominator by sec A minus tan A because it is plus here. So sec A minus tan A into sec A minus tan A upon sec A plus tan A into sec A minus tan A. So in the numerator it will become sec A minus tan A whole square. Denominator it is A plus B, A minus B. So it will become sec square A plus minus tan square A. Okay. So now down denominator will become 1 and then the numerator will write first we will expand, that is sec A minus tan A whole square. So it will become sec square A plus tan square A minus 2 sec A tan A upon this is 1. So what we have used? We have used A minus B whole square is equal to A square plus B square minus 2AB, and also we have used sec square A minus tan square A is equal to 1. Okay, so this implies again sec square A can be written as 1 plus tan square A plus tan square A minus 2 sec A tan. Why? Because sec square A is equal to 1 plus tan square A. That is what we have used. So now this becomes 1. Then we have 2 tan square A tan square A 2 tan square A minus 2 sec A tan. So this becomes again 2 tan square A that you keep as it is. So this can be written as per the RHS they have given 1 minus 2 sec A tan A plus this just changed according to the RHS order. So this is nothing but this is equal to the RHS. So therefore LHS is equal to RHS, hence proved. Now question 21, homework for you. Prove that sin A plus cosec A whole square plus cos A plus sec A whole square is equal to 7 plus tan square A plus cos square. Try it out, apply A plus B whole square formula to this and to this. Then you can write this cosec, wherever you have cosec you can write as 1 upon sin A. Try it out, you will get it. Okay, you will be using cosec square A is equal to 1 plus cos square A and sec square A is equal to 1 plus tan square A identities, then you will be getting it. Try it out. If you don't get, you can ask me. Then question 22. Prove that sec square A cosec square A is equal to tan square A plus cot square A plus 2. So again consider LHS, that is sec square A dot cosec square A. Okay, so this implies sec square is 1 upon cos square A and cosec square A is 1 upon sin square A. So what have we used? We have used sec A is equal to 1 upon cos A and cosec is 1 upon sin A. Okay, so this is now one can be written as sin square A plus cos square A upon cos square A sin square A. Okay, or we can add one more step. 1 upon cos square A sin square A. Then you write 1 as sin square A plus cos square A upon sin square A cos square A. The identity that we used is 1 is equal to sin square A plus cos square A. Okay. So this, if we separate sin square A upon sin square A cos square A plus cos square A upon sin square A cos square A. So sin square A cancels, cos square A cancels. So this becomes 1 upon cos square A plus 1 upon sin square A. So 1 upon cos square A is sec square A plus 1 upon cos sin square A is cosec square A. Okay, so sec square A is 1. Here what we have used? We have used 1 upon cos A is sec A and 1 upon sin A is cosec A. Now this sec square A can be written as 1 plus tan square A and cosec square A can be written as 1 plus cot square A. So here we have used two identities. One is sec square A is equal to 1 plus tan square A and the other one is cosec square is equal to 1 plus cot square A. So this implies 2 plus tan square A plus cot square, or it can be written as like the one given in the RHS, tan square A plus cot square A plus 2, that is equal to your RHS. Therefore LHS is equal to RHS, hence proved. Now question 23 you do as homework, that is prove that 1 upon 1 plus cos A plus 1 upon 1 minus cos A is equal to 2 cosec square A. Similarly, the next 24th question is also homework. 1 upon 1 minus sin A plus 1 upon 1 plus sin A is equal to 2 sec square A. Very easy sums. Try it. If you don't get, you can ask. Okay. Then question 25. Question 25 is prove that cosec A upon cosec A minus 1 plus cosec A upon cosec A plus 1 is equal to 2 sec square. Okay. So again consider LHS, that is cosec A upon cosec A minus 1 plus cosec A upon plus. Okay. So let us do cross multiply. So cosec A into cosec A plus 1 plus cosec A into cosec A minus 1 whole upon cosec A minus 1 into cosec A plus 1. Okay. So now when you remove the brackets, you get cosec square A plus cosec A plus cosec square A minus cosec A upon cosec square A minus 1. Okay. Now what all we have used? We have only used A minus B, A square minus B. Okay. So now this is cosec square A and cosec square A is 2 cosec square A plus cosec A minus cosec A get cancelled. So you get 2 cosec square A upon cosec square A minus 1. Now cosec is reciprocal of sine. So this can be written as 2 into 1 upon or sine square A, okay, upon 1 minus sine square A minus 1. This is because cosec A is equal to 1 upon sine. So this implies 2 upon sine square A upon this becomes 1 minus sine square A upon sine square A. Okay. So this is when you multiply with the reciprocal, this will become 2 upon sine square A into sine square A upon 1 minus sine square A. Now I have taken the reciprocal of this fraction. So sine square A cancels. So this becomes equal to 2 upon 1 minus sine square A. But 1 minus sine square A is cos square A. So this implies 2 upon cos square A. This is because 1 minus sine square A is equal to cos square A. Okay. So 1 upon cos square A is sec square A. So this implies 2 into sec square A, that is equal to RHS. Therefore LHS is equal to RHS, hence proved. Okay. Now homework for you. Question 26. Sec A upon sec A plus 1 plus sec A upon sec A minus 1 is equal to 2 cosec square, a similar one. Then 1 plus cos A upon 1 minus cos A is equal to tan square A upon sec A minus 1. Okay. Now in this hint, if you take RHS, you will get it easily. Cot square A upon cosec A minus 1 whole square is equal to 1 minus 1 sin A upon 1 plus sin. Okay, here you can take cot A as cos A upon sin A, and cosec A as 1 upon sin A, then you will get it. Okay. Question 29. 1 plus sin A upon cos A plus cos A upon 1 plus sin A is equal to 2 sec A. Okay. Try to do this. If you don't get, ask me doubts, and then we will proceed further in our next class. Okay, children. Take care. Thank you for watching. God bless you.